Hello students, welcome to On to Classroom Sessions. So let me introduce myself. I am Brahma Vasu. I have done my MTech in reputed institutions called NIT Kurukshetra in Haryana state. So in the year of 2014 to 2016. Since then, I have been working in Akash Institute in one of the branch located in Hyderabad. I'll be teaching physics to the JEE mains students and to the NEET students. So I am being a senior physics faculty at Akash institution and I have 5 years experience in teaching physics. Thank you so much. In this video lecture, I'm going to discuss the concept called diode. So basically, diode is a two-terminal. Basically, diode is a two-terminal non-linear device. So it is a two-terminal non-linear device. So it means that it has two terminals. So I am showing you schematic symbol of the diode. So these are the two terminals of the diode I am discussing. This is called anode terminal and this is called cathode terminal. So this side we'll be calling this as P side and this side we'll be calling it as N side. How this diode is going to work? What is the principle of this diode? What are the characteristics of the diode or the things that I'm going to explain now? How this diode is going to behave is, suppose if you provide some voltage here, then it starts current flowing through the diode. So upon applying some voltage to the diode starts conducting. When V is greater than 0, I will be greater than 0. Suppose if you give applied voltage less than 0, then current through the diode is simply equal to 0. So basically, this is regarded as the diode working principle. This is regarded as the diode working principle. So I can say that whenever the current is more than 0, I can say that this diode is forward biased. And whenever I through the diode is equal to 0, it is regarded as reverse biased. So strictly speaking, these are the two regions of operations of diode. Either the diode can operate in forward bias or the diode can operate in reverse bias. If current is greater than 0 through the diode is forward biased. And if current through the diode is 0, then diode is reverse biased. So these are the points you have to understand about the diode. So as I was mentioning a point, this is the schematic symbol of the diode. So this terminal I was mentioning, like this is anode terminal and as usual this is cathode terminal. This is P side and this is N side. One thing everyone has to note a point. the current through the diode always flow from P side to N side. So the diode will not allow the current from N side to P side. Upon applying the voltage V, diode will start conducting, and the current through the diode is given as, let me give you a current expression through the diode, and that is I is equal to I naught into e power V by beta Vt minus 1. So this is the basic current relation or basic current expression through the diode. And let me explain you each term in this expression very clearly so that you will understand this expression in a proper manner. So let me take the different pen color so that I can explain each and every term in the expression. So this I naught is regarded as reverse saturation current. So please note this. This I naught is regarded as reverse saturation current, and the order of this I naught is 10 power minus 13 amperes. Yeah, so this is reverse saturation current to the diode, and this Vt is thermal voltage. This Vt is thermal voltage, and the value of Vt is given as Vt is equal to KT by Q. So the exact value of Vt is to be taken as 25.8 millivolts. And finally, the need is a constant. It is 1 for silicon diode, and the value of neta is 2 for germanium diode. So these are the points I would like you to note down about the diode. Simply, I can say that very important point I would like to tell you that when applied voltage is greater than 0, which means when voltage is positive, current will be greater than 0 to the diode. Then we will simply say that diode is forward biased. Please note this, FB stands for forward bias. And similarly, if applied voltage is less than 0, then current through the diode is 0, then diode is simply reverse biased. So these are the points about the diode. And one more thing I would like to mention here without missing that point. So suppose if you consider a resistor, and for the resistor we are providing voltage V, and upon providing voltage V, I flows through the resistor. What is I? Very good, current. So what is the relation between current and voltage in a resistor? It is given as I is equal to V by R. So basically this is Ohm's law. So let me tell you the statement of Ohm's law now. Ohm's law states that current in a resistor is directly proportional to V. So current in a resistor is directly proportional to V, which means they are linearly related to each other. So I and V are linearly related to each other in a resistor device. But having said this, Let me be precise about the diode now. If you consider a diode, and I was already mentioning this point to you just previously, upon providing the voltage V here, you're going to get current I. What is the relation between the current I and the voltage V in a diode? We are saying, we are mentioning that I is equal to I naught into e power V by neta Vt minus 1. And I was confidently saying that these two, which means I and V in a diode, are related exponentially. So in the sense that I can relate this I as proportional to e power V, something like this. So this is the kind of expression we are getting in a diode. And having said this, I just want to tell you that this relation is entirely different from the resistor. So in the resistor, we got a peculiar relation that I is equal to V by R. But in the diode, we are getting I is equal to I naught into e power V by neta Vt minus 1. So this is the relation we are getting for a diode. Therefore, resistor is a linear device. Therefore, this is the conclusion. Resistor is a linear device. Why we are claiming that resistor is a linear device? Because current in a resistor and the voltage in a resistor are linearly related to each other. And now, what is the conclusion part for the diode? What can you conclude about the diode? Very good. So diode is simply non-linear device. Diode is a non-linear device. So let me write here very clearly. So diode is a non-linear device. So why we are claiming that diode is a non-linear device? Let me take the eraser here. Let me erase this part. So diode is a non-linear device. So this is the major difference between resistor and the diode part. So basically, resistor is also having two terminals, and the diode is also having two terminals. But the major difference between the resistor and the diode is that in a resistor, the current is linearly related to voltage, but in a diode, current is exponentially related to voltage. So upon saying this, I can conclude that resistor is a linear device and the diode is a non-linear device. See, I would like to mention an important point about the diode. Let me clearly explain to you. Basically, so just one point. So diode is a, in simple words, if someone is asking you what is diode, you say them that diode is a two terminal. It has two terminals anyhow we have seen, and it is non-linear. So why it is called non-linear? Because we have seen that in a diode, I is related or I is proportional to e power v. So that's why the diode is non-linear and it is passive device. So now you can ask me, sir, you have explained about two terminals of the diode and you also have explained about non-linearity characteristics of the diode. And you can ask me, sir, what is this passive means? Let me explain this to you for a moment. Passive means there is no built-in source of power. So passive means there is no built-in source of power. So you can understand this. Let me explain this to you very clearly. What is this built-in source of power is, if you consider a diode symbol, you have only two terminals, you will give V and you get current I. And here we don't have any scope of giving supply to the diode. Such a device in which we are not having scope of supplying voltage, so those devices are said to be passive devices. And one of the most important passive devices, diode. One of the most important passive devices, diode. Now, you can freely ask me, what are active devices? Yes, I'm going to explain that to you. Suppose if you consider a BJT, it is an active device because here you have scope of giving supply. So when you have a scope of giving supply to the device, such devices are very important devices and they will be coming under active device section, but this diode will be coming under passive device section. Upon explaining everything about the diode, I just want to conclude by saying that so diode is a two terminal. It has two terminals, I have told you. It has P side and N side. And this P side is also called as anode terminal. And this N side is also called as cathode terminal. And now it is a non-linear device. I can claim that this diode is non-linear device by the equation that I is proportional to e power v. This is the only relation, this is the only significant relation claiming that the diode is non-linear device and it is also passive device because here for the diode we are not able to provide any supply voltage. So therefore, diode is a two-terminal non-linear passive device, whereas the BJT is the proper example for the active device. So thank you so much.